not visible or if there is any issue in sound or video, right? So let me go through this example, which was very simple example, and that was actually a portfolio optimization problem, right? And that problem is related to finding the optimum weights such that the given return, which is 0.11% in this case, right, will be, you can say, met. Also, there are some condition placed that no short selling allowed, and the portfolio has 3 weights. So, the summation of the weights W1 plus W2 plus W3 is equal to 1, and also it is given that no short selling allowed. That means no W1, W2, W3 can be a negative or greater than 1, means this W1, 2, 3 are strictly between 0 and 1, including 0 and 1. Okay. So, that is the condition given. Also, we have given the expected return from individual assets, means E of R1 is 0.1, E of R2 is 0.08 and E of R3 is 0.12. So, individual returns from the 3 securities are known. Also, the variance of the 3 assets, means risk of the 3 assets are known, that is sigma 1 square, sigma 2 square and sigma 3 square, right. Variance means sigma square, and they are uncorrelated. So, there is no covariance, means sigma 1 2 is 0, sigma 2 3 is 0 and sigma 3 1 is 0. If sigma 1 2 is 0, sigma 2 1 is 0, and if sigma 2 3 is 0, that means sigma 3 2 is 0, and if sigma 1 3 is 0, that means sigma 3 1 is 0. So, indirectly we have given the covariance matrix sigma. Okay. So, now all things are known, the expected return matrix is known, the sigma matrix is known, we have to find the optimum weights and we have to use the MATLAB for solving the equation. So, we do not have to solve any optimization problem ourselves, right. Let MATLAB do it for us, because we have already solved that optimization problem in our theory lecture and we have found some derivation, and I told you it is an open book exam. So, you can use any equation which is readily available with you, and let me go to the general portfolio optimization problem that we have solved, right, using the Lagrange multiplier, right, that is Lagrange multiplier. So, if you have listened carefully in my lecture, I frequently told you that refer to this optimization problem very carefully, because we need to use it so many times. So, let I go to that particular problem. So, see, we have seen this a particular case which is a 3 asset portfolio where we have to find the optimum weights W1, W2, W3 given this covariance matrix, okay, and the expected return that we have solved manually, using this differentiation equal to 0 and all these things, right. So, we have solved this manually, right, and that one type of such type of example is also there in my PPT, right. But we are mostly interested in the generalized solution so that we can implement it easily in MATLAB. So, for that I go to the N asset portfolio and its general solution. Yeah, this is just a minimum variance. Let me go to this. Yes, this is minimum variance portfolio for 3 security, and then yes, this is the derivation that we have done. So, this is optimization problem example, derive efficient portfolio for n risky security case using matrix notation. Because in MATLAB when we enter, we need the matrices, data should be in a matrix, that should be very carefully understood by you, right. If you are not understanding these basic things, how to handle data, you forget you can learn anything in data science, right, and even if you learn, it will not be long lasting. So, be careful about the fundamentals. If you want to long lasting career in this particular field, then be careful about the fundamentals. The fundamentals will never change, whatever be the other things that will keep on changing, but fundamentals will never change. So, let me understand this. So, we have to find what the optimum value of this W vector, which consists now W1, W2, W3 in our case. It is 3 asset portfolio. Okay. So, that is this example for n risky security case. Now, we are taking the 3 risky security case W1, W2, W3 as per given data. This expectation vector E I can have, this U is a vector of 1 which I can frame, it is n cross 1. So, I have to frame it 3 cross 1, right. And this optimization problem is already there, which is solved here in theory by taking this Lagrangian, and it is given that the solution is obtained by this particular equation. What is that? This portfolio weight WP bar, or you can say the minimum, the portfolio weight such that the variance is minimum, is given by WP bar equal to G bar plus E of RP into H bar. E of RP is given return, the given expected return, which is given 11%. So G and H need to be evaluated. G depends on what? It depends on E vector, sigma vector, which is known, U vector, it is vector of one known. B, it depends on B. Here this H depends on C and D as well as A. So we have to find this A, B, C, D, which can be found using U, sigma and E, right, which are given. So we just need only two things, this E vector and sigma vector. U is already vector of 1, so which we can easily write. So from that we can find A, B, C, D, G, H, and then we substitute here in WP bar to find G bar and WP bar to find the optimum weight given this ERP, right. Let we write it in the proper form in Word document, and then we write it in a MATLAB. Need not to do anything yourself, MATLAB will do all this for you to solve the equation. So let me write it in a proper way. So first of all, let me write what are the data given to us. I hope this is particularly visible. So what we have given? We have given this covariance matrix sigma. Let me write it. We have given this sigma matrix. How to write sigma matrix? Now can anybody tell me? From this data, what will be my sigma matrix? It's a covariance matrix. It will be 3 cross 3 because I have a 3 asset portfolio. How to write sigma matrix? Can anybody? If you interact, then only it will be useful to you, right? And remember, now onwards we have the units which are utilizing intensive mathematics and statistics. So it will become more and more difficult kind of thing. So forget then scoring in the exam. What will be sigma matrix?
Elements other than the diagonal will be 0.
Yeah, so that diagonal elements are simply 0.01, 0.02 and 0.008. That's it, and all other elements are 0 because the securities are uncorrelated, so their risk, or you can say covariance, are 0. Okay, so the related risk is 0. So I can say this matrix which is having data 0.01. This diagonal element 0.01, 0.02 and 0.008, and except that all others are made to be 0. Then we know the E vector. The E vector is the vector of the individual security return, which are also given. So that is the E vector, which consists of which value? That is 0.1, 0.08 and 0.12. So let me write this, and it should be vector. So if we write in a row form, then it should be transpose. So this vector is sorry. So this vector is to be written like this. Just wait, this pen is not loading. Yes. This is 0.1, then 0.08. If anything is in percentage, you have to convert into fraction. But here I have given both the values for your convenience. So you will not make any mistakes. Still you are making mistakes. So this is my expected vector. Now U vector, which is vector of 1 of 3 cross 1 here, because we are having the weight vector which is unknown, W1, W2, W3 transpose. When we say vector, it should be column vector. So when we write in a row form, it should be having transpose sign. Okay. Now everything is given. So what you need to calculate first? So you just write here. So first you find what? First you need to find this capital A, B, C, D. That's what equation says you, right? You go to this theoretical discussion, you need this A which depends on U sigma inverse E. We need not to do inverse ourselves. MATLAB will do it for us. Then A, B, C, D once known, then G bar, H bar vectors we can calculate. So second step is to find the G bar, H bar. Once the G bar H bar is known, the E of RP, the expected return from portfolio, is given, and what that is? E of RP is what? It is given in problem. The expected return from portfolio is 0.11. So we have to find the weight such that the expected return from the portfolio is 0.11. So right here 0.11. Okay. So from that, what you can calculate? If E or RP is 0.11, you can calculate the WP bar, and if this WP bar vector is known, now I can find the risk of the portfolio. What is the risk of the portfolio? It is sigma p square. And what is sigma p square? WP transpose sigma WP. So a sigma vector is a sigma matrix is known. And last part, what we need to calculate is the last thing. So you can see the questions. Weight W1, W2, W3, we can find it from weight vector. Variance of portfolio, that is the risk associated with portfolio, sigma p square. Now in last question, there are some more data given. Now the market beta is 0.9 and 3 stocks have beta equal to 0.7, 0.8, 1.1 respectively. Then portfolio beta. So how you can calculate this? You just tell me. This is slightly tricky, but not, you have to use your common sense. Now you have invested in these 3 portfolios. The betas of that, I told you in the theory lecture how to find the beta. The betas are available on some websites. So now these betas are known. The investment proportionality that you have determined by W1, W2, W3, and you want to find the beta of your portfolio. So what's given to us and how to find the beta of your portfolio? Can anybody tell me? I want to find beta of portfolio. This is very common sense. If you are not applying any common sense in finance, then there is no way. I want beta of my portfolio given, let's say, beta vector, which is say beta 1, beta 2, beta 3, and let I write this value, say beta 1, 0.7, 0.8, 1.1, 0.7, just bear with this pen and all that. 0.7, 0.8, 1.1. So let I write beta vector is given. How can you find beta of portfolio? My portfolio consists of 3 security and individual betas are known. It's very simple. I want answer from you. Anybody? Nobody has solved this and even not written anything in the solution uploaded. What it will be? So it is WP transpose multiplied by beta. So that is nothing but W1 beta 1 plus W2 beta 2 plus W3 beta 3. That's it. Right? Now let we solve this using MATLAB. You have to write only this thing in our solution. It is not more than even a half page. This is just a full page because I have written it with the larger font in this Word document. If you write it in your notebook, it is not even a half page, right? All things now is to be done in the MATLAB. Let me do it in MATLAB. So let I open my MATLAB. Let my MATLAB online is to be opened. Let you wait, just this MATLAB is open now. Okay, it is loading. All right. So now what should I type first? Just I will use the command prompt. I am not preparing any M file. Let I use command prompt. So what should I write first? I should enter these three things first. Whatever data needed, that I should enter this sigma matrix, E vector and U vector. Okay. Then I write the equation of ABCD in this MATLAB. So let me do it. So already I have done some time before it. So let I recall from that. So let I write first of all this sigma matrix. Say I indicate it by S. So see, I have entered S equal to 0.0100, then semicolon 0, 0.02, 0 and 0, 0, 0.008. So that is my sigma matrix. I denoted it by S for simplicity. Let I say, okay, this is the matrix. Then I should enter E matrix and U matrix. I have done this sometime before. So let my say E matrix is what? 0.1, 0.08 and 0.12 dash. Why there is a dash? Transpose. Don't make mistake in that. Press enter. You will get a column vector. Okay. Then you should enter the U vector, which is vector of 1 with size 3 cross 1. So don't make mistakes in this simple things. 1, 1, 1 dash. So it is 1, 1, 1 transpose. Okay. Now all data enter. So let us use this equation of A. So I go to theory. What is equation of A? A is U transpose sigma inverse E. Now take care about it. It is U dash multiplied by inverse of S multiplied by vector E. So accordingly, I have to write the MATLAB command. So in MATLAB, remember the matrix multiplication and the element to element. Here we have to use the matrix multiplication. All these are matrix multiplication. Okay. So take care about this. So let I find this A, which is already there. So I recall that. Okay. So you can see it is U dash inverse of S into E and press enter. So this is my A. You can see, just compare it with theory. I am opening it again. What is A? U dash sigma inverse E. How I have entered in MATLAB? U dash inverse of S into E, and this sign is simply star. There is no dot star. If it is a dot star, it will be element to element. Here it is matrix multiplication. Okay. Then similarly B. Let I go to B. What is B in theory? B is E transpose sigma inverse E. So I have to write E dash inverse of S into E. Press enter. So you get B, then C. What is C? Let's refer to theory. C is what? U transpose sigma inverse U. All equations are available with you. No need to remember anything. And what's difficult in writing this equation? I don't understand. We have used even tougher than this in the signal processing. This is U dash inverse S into U. And finally D. So what is my D? Just a minute. Wait. D is simply BC minus A square. And BC and A all are scalar. Okay. So or you can see simply D equal to C minus A square. So BC minus A into A. Press enter. So now A, B, C, D are known. So now I can calculate the vector G and H. So what is vector G and what is vector H? Vector G is this B sigma inverse U minus A sigma inverse E divided by D. So I have to write it. Let I go to that. Yeah. So you can see how I have written B sigma inverse U minus A sigma inverse E divided by D, because all things are known. You can compare this again with this B sigma inverse U minus A sigma inverse E. It is there? Yes. Press enter. The numerator, two terms are there, which is matrix multiplication, right? And this D is a scalar, so it just divides every element of this whatever subtraction of matrix by D, and it finds this G vector. You can see it's a 3 cross 1 vector. Similarly, H. So what is H? H is C sigma inverse E minus A sigma inverse U divided by D. So let us use it for H. Yes, C sigma inverse E minus A sigma inverse U divided by D. Just press enter. So MATLAB will do all this calculation. We need not to find any inverse multiplication, anything. Okay. Now G and H available, so I can find my weight vector very easily. What's the equation? The weight vector is G bar plus ERP into H bar. I need only ERP. I have to define this ERP. Let I define it, right? So I define it, this ERP, where this ERP is yes, I have defined in variable say ER, which is 0.11. Okay. Whenever there is a percentage, we have to write it in a fraction value. And for your convenience, I have given in both the right case, the fraction value and the percentage in brackets. You will not make any mistake. Okay. So now I use the equation of WP, the WP bar. So what is my vector WP? So that is G plus H into ER. ER is a scalar, so I can write it ER into H or H into ER. No, there is no difference. And that's my portfolio, which gives me this risk, which is minimum with the given return, which is 11%. So I want an 11% return with this kind of security, which has individual return risk known, and I can frame this portfolio with this weight vector. Okay. Then this weight vector is known, so I can populate this 0.3235, 0.082, 882, 0.5882 in my answers. So you can populate it, right? So these are the first three answers. Then you have to find the variance of portfolio, means sigma p square. What it is? W p transpose sigma w bar. So let I calculate this. So the variance of the portfolio or risk of the portfolio given by variance is this. W transpose means W dash. S means here this sigma into W. Press enter. This is risk 0.040, right? So that's you have to populate here, right? So that's it. So that was the risk given by portfolio. Then the beta of the portfolio. Now we don't know the beta matrix here, but we have given this beta matrix. So I have already created this beta matrix in theoretical discussion. So beta bar is what? 0 0.7, 0 0.8, 1.11. The WP bar matrix I have calculated. So I have to just frame the beta matrix and then write WP transpose into beta, which will be my portfolio beta, the portfolio of the beta. So let I define the beta matrix. I have written this beta matrix like this: 0.7, 0.8, 1.1 dash. It is transpose. That is 3 cross 1 vector. Then find the beta of portfolio. This beta of portfolio, it is W transpose into beta. So beta P is this, that is 0.9441, and that's what you have to populate as the last answer. And that's what our problem is solved. Now you can see the individual betas are 0.7, 0.8, 1.1, and market beta is 0.9. Okay. And my portfolio beta is 0.9441. So it is very near to this market beta. By using this optimization, you can see I am very near to this market beta. Even though the individual security, some security has beta very much less than 1, say 0.7, and another security has beta greater than 1, 1.1. The overall beta of the portfolio with these weights, right, for the given return and minimize risk, right, I am 0.94441 beta, and if you compare with market beta, it is slightly greater than market 0.9, and here it is 0.9441. Okay, market risk will be always there. So, but in that case, what is the thing that we have achieved? We have expected return of 11%. So we have tried to minimize the risk for obtaining this return. Anyhow, in future, how it will progress, that depends on the market. But at least we have taken this care. We have designed a very good portfolio. Are you getting this or still any doubt? This problem is not for only examination, it is used to solve your doubt or solve your, you can say, vision. This is problem solving, right? So we care about this example. These are data which I am taking a very serious real world data. It is not only for solving mathematics. If you relate it with physical world, then it means. So any doubts right now? I want to listen from you. Whether anything out of syllabus or anything difficult, you have to use only single slide, right? Nothing to be solved manually. You have to just write data on page and then use the MATLAB, okay? And in solution, you have to upload only this data, right? These particular steps, and at the most, you can populate these, copy paste these MATLAB commands, right? You can copy paste these MATLAB commands, which easily you can do it, right? Or if you wish, you can also populate this answer, individual answers, so that your steps will be justified and you will be given full marks even though your final answer is wrong. I have given some extra marks for the solution upload, but no, I found nobody up to the mark. Nobody has written complete solution. Any doubt? I'm taking a pause of half minute, 1 minute. You just refer yourself and tell me if there is any doubt. I will upload this solution also. So let I copy paste whatever I have done today, so I can upload it. So later on also you can refer for your final examination. Let I copy in Word. So where to copy? Here. And it is a single command, Control C, Control V. Where is the difficulty? I don't understand. What is the difficulty when you have all these tools and all other things available? That's complete solution. Just save it, convert in PDF and upload it. That's it. So I am very much eager to listen doubts from you. So many students try to solve it using this 3 portfolio case, which is also one of the way, right? They have tried to solve the optimization problem numerically, like we have solved here for 2 security case, or that's possible, but that is very lengthy and you will not able to find up to the last for any generalized case. So use the generalized case, because the generalized case is the, you can say, where we can implement in a MATLAB very easily. Yeah, this was the case we have exclusively solved for the 3 security case. Manually we have solved using the partial derivatives and all things, right? But that is for minimum variance portfolio, right? It is not for given written. So I'm eager to listen any doubt. Okay, if you have no doubts now, then you tell me which other questions you find difficult, because rest of the other questions are very simple. The MCQs are perfectly, you can say, obtained from the material. You can solve all the questions very easily if you refer to my PPTs. No way to go outside. Only there are some data here and there that you have to just collect. You just tell me which other part you find difficult. If you tell me, I can able to guide you or solve this here. I will upload this complete solution. Any MCQ or anything in question 2 you find difficult. These all questions are actually tricky questions, right? Where you can relate it with the real problem. It's not just to substitute an equation and get the answer. Sometimes you are making the mistake when standard deviation. Sometimes I'm specifying standard deviation. So when there is a standard deviation, what it means? It is only sigma. When you want to find variance, you have to square it. And when standard deviation is given by percentage, you have to first write it in a fraction value. The standard deviation is 5%, so 0.05. So the risk means variance is what? 0.05 square. So that you have to take care. And return given in percentage, just convert into fraction value. So here risk-free rate is 4%, so it is the interest rate. So that you have to convert into 0.04 fraction value. When you have to populate answer in percentage, you have to multiply your fraction value answer by 100. So that common sense you should have. Everything is written, instruction is written in every question. So I don't think anything which is there are sort of data or misleading. All things are there in the question. You have to just carefully read it and interpret it. Yes, I am listening nothing from you. That means everything is clear to you, right? And again, you are making mistake by keeping yourself silent. Because now onwards we are moving to modeling and other things where there is a huge statistics and you have to use the MATLAB in a great way. Otherwise, manually you forget you can solve anything. Now we start the practical sessions with the MATLAB for portfolio optimization, then with the modeling. So where you need to use all these equations that we have studied in theory in the MATLAB, right? But that solution you can only obtain using MATLAB. So very careful about it. So I hope this particular thing is clear. So I will upload this solution, right, of this question 3, and rest of the others are, I think, very straightforward. So if particularly if you tell me, I can find the solution for you here and upload it. Otherwise, if you are able to calculate it yourself, because this is just a substitution in equation by interpreting data properly. Otherwise, there is no analytical part involved in any other question, whether it's MCQ or part 2 assignment problem. Only small mathematics.
Sir, can you please help us with 13th one?
13, this one.
Yes, sir.
Okay. So what is given here? This consider a one period asset pricing model where the values of stock at time t equal to 1 is S1 and it can be S1 equal to 110 or S1 equal to 90, each with probability 1/2. So let the risk free rate is 5%, beta is given 0.2 and the expected return of the market is 9%. Then in CAPM framework S0, right, which is the current price of the stock. So how you proceed? So from this we have given that right now I am at time t equal to 0. I am purchasing right now, and at some time t equal to 1. T equal to 1 doesn't mean it is 1 day or 1 month. At some time, let's say whatever my horizon, say 1 year, it will be either 110 or 90, but the probability is equal 1/2. So first of all, I need to find the expected value of this stock at t equal to 1. Whenever there are probabilities associated with anything, you have to find its expected value, which is the average value. Remember, expected means average value. So first you find expected value of S1, E of S1. It is what? 110 into 1/2 plus 90 into 1/2. So you can solve it very easily, right? So that will be the expected value of stock at S equal to 1. Now other data are given. So we have to use the KPM framework. So how you go with this? Which equation you use? Let I open my CAPM framework slide. So I go to CAPM. This is capital market line and CAPM. Yes, this is CAPM framework. So this is the CAPM equation. Expected return. Now I have RF available, E of Rm available, right? This RF is given, beta is given. So what I can calculate? Expected return now. Are you getting? From this given data, I am again opening my question. So see, RF is given, beta is given, E of Rm is given. So now you are having this thing available, E of Ri. Now what is expected return? It's very simple. I have invested at t equal to 0, right? And I am having some value available at t equal to 1. So you can find what is return. Are you getting it? It is what? S1 minus S0 divided by S0 and compare it with E of Ri. Now one thing is known, that is what? What thing is known? The S1 is known. So you can calculate S of 0. Only one unknown is there. Shall I write in my notepad? Or is it clear? Yeah, shall I write it? Yes. So let I write it. So I use this pen. So first of all, what I do, I calculate E of Ri using the given data because it's a CAPM framework. So all things are given. So you calculate this E of Ri. Okay. This is for question number 13. Okay. So there is a CAPM equation and all things are known. Now I have given S1 how? It is 1/2 into 110 plus 1/2 its average value. Because it can be 110 or 90 with equal probability. So the average value or expected value of S1 is this. So I can write actually expected value of S1. This will be 100 and so it will be 100. Now the E of Ri, I have calculated it from the CAPM equation. What it is? It is expected value of S1 minus S0, which is unknown, divided by S0 in a fraction value. Now E of S1 is known, E of Ri is known, so you can find this S0 value easily, this today's stock price. So this can be calculated. Yeah, tell me if it is clear.
Yes, sir. Thank you.
Okay. So nothing is outside these slides. You have to apply your common sense. Because in a financial world, there are so many data, and that's why deal with data is very difficult in most of the case. We are taking very simple cases. Still, I want to listen from others. Most of the equations related to CAPM equation because that's very important. That's why I have taken this CAPM equation in almost all parts. Because CAPM compares your return with the market return. All right. So I think today we will not start a new session, but tomorrow we should start with the unit 2 where we have left in the last you can say lecture, which was before our internal assessment. I just quickly remind where we have stopped in the last lecture. So we have started unit 2, which is related to the time series modeling, right? So we have started with the definition of econometrics. Then we have seen what is time series data, then time series basically a outcome of the random process, and we have seen a classification of random process which is either stationary or non-stationary. We are interested in a stationary random process, and there are conditions associated with a weak stationarity condition, which is the mean should be a constant, it should not be changed when time frame is changed. The covariance should be function of the leg only, okay, and variance should be also finite and constant. So there are some conditions on the time series data, right, so that it can become a stationary, and we are interested only in the stationary random or stochastic process. And then we have seen a simple linear time series model using the leg operator. So you just recall it, the slides are uploaded, and we have seen its polynomial representation, the filter representation. So any time series yt can be, you can say, written as this linear equation, which is nothing but output of the linear filter, which has coefficient given by this polynomial psi of L, and input is a white noise, right, say epsilon t. So all the random, all the, you can say, the time series data can be modeled by using this particular filter model, okay. And we have seen if the time series is stationary or non-stationary, how I can calculate? I can perform the unit root test, okay. And we have seen a unit root process because this polynomial psi L is particularly, you can say, infinite, which I can consider to be rational polynomial. It is ratio of two polynomials, and I can have the pole 0 representation or numerator denominator or transfer function representation, okay, with finite number of coefficients, right. And that we have seen. If series is non-stationary, unit root test that says that if there are roots which are outside unit circle, this series is non-stationary, means system is unstable, and we can make it stationary by using the difference operation, that also we have seen, okay. Then we have seen some pre-processing to make the data stationary. One of that is differencing. Then another we have seen by taking the log operation if the mean is exponentially increasing, right. Detrending is one kind of subtraction. So we have seen this detrending means we have to remove this mean, right. So we have to detrend the process. Then we have to make it stationary by using subtraction. If it is exponentially rising, we can use the logarithm of it, and then we can make it very much look like a random stationary process, okay. So this pre-processing operations you can refer, okay. That's what I just try to recall you. You refer today, and tomorrow I will start with the ACF and PSEF, which are autocorrelation function and partial autocorrelation function. So before I start, I request all to refer to all these 18 slides which I have already uploaded, so that you will not have any lag in understanding. Otherwise, you will not able to understand so many terms which we are now referring in the model. And then we use MATLAB to solve this model and to forecast the stock price from the given historical price. But that will be after understanding each and every term and each and every equation, okay. So it is better for you to recall all these 18 slides of unit 2, which will be now part in your IA2, okay, which will be now part of IA2. So I hope if still any question in IA1 or in unit 2 what we have started, you can ask me. Otherwise, I end this meeting, and tomorrow I will start with ACF and PSEF in the unit 2, which is related to time series modeling. But before that, you must refer to all the 18 slides of unit 2. So you will not have any lag in understanding this time series, okay. So let I minimize all. And I stop recording.